I would like to thank the organizer for inviting me, and it's a pity that I couldn't be there, but I hope that the next year I could. So, I am Alessandro Seganti, and I am a data engineer at Cognitum. Today I would like to present you how to model ontology using Fluent Editor and Ontorion Server, that are two software that we are developing at the moment in Cognitum. So I would like to start doing a brief introduction about the Semantic Web and OWL, RDF, SparkWell in general. And then I would like also to present to you the OntorionCNL, that is a controlled natural language that we are using here to model ontologies. So I will start. I don't know what's the level in the audience, but I think that I assume that you are not familiar with this. But if it's too easy, if you have questions, you can ask me. So the semantic web, the idea behind the semantic web is that that it's possible to model ontologies using a language that is called OWL, and this language, the interesting part of this language is that it's implementing some logic, but also using this language it is possible to reference other ontologies, and this image is to show that it is possible to have these ontologies on your on a database, for example, or to have them locally on your computer, or to have them on the internet. Furthermore, there is a subset of OWL that is RDF, using with which it's possible to build graph databases. On top of all this, there is another W3C standard, that is SparkWell. SparkWell is the equivalent of SQL for relational for this kind of linked data. And so it's the idea is similar, but on the other part, underneath, SparkWell is working in completely another way, and so it seems similar, but in reality it's much different than SQL. So OWL is an implementation of implements description logic. At least the OWL that we are using, and the one that is one of the most popular, OWLDL. And but in OWL you cannot express everything. And also in DL during the years there is another W3C standard that has entered, that is the SWRL. These are rules that is possible to write and to add in a OWL file, to add rules between that is relating concept, instances, and properties. So our OntorionCNL is CNL that is controlled natural language. So this means that it's is not a natural language, but it is a language with a strict grammar. This means that for us, this is important because when you have a controlled natural language, you can parse it simply. But on the other hand, it's also a language using which you can express also very complex things. So our OntorionCNL was designed to be compatible with OWL and SWRL. So it's completely compatible with these two, or at least with the SWRL part that is DL safe. And we are developing at the moment the part that is not DL safe. And but furthermore, it's also possible. It's our CNL can be compatible with SparkWell, in the sense that it's possible to do CNL queries using our controlled natural language. It's possible to do queries, and these queries can be translated to SparkWell. So now I would like to present very briefly, but just to give an idea of how it is possible to write this, the things that generally are written inside an ontology, so concept, definition, instances, and so on and so forth, in 3 ways. So first of all, I would like to present it in description logic, and as you see, description logic is a mathematical way of writing things. I don't know, for me that I have a mathematical background, this is probably the most intuitive one, but you will see that maybe for you it's not. So here what I am doing is that I am defining a city that is name is New York and that belongs to New York State. So in OWL this is possible to write like this. OWL is it uses the XML format, so it's possible, it's this is because using XML is simple to represent hierarchical data. So in this case, so you see that there is similar things that were written here. So we are writing that that this is a city and its name is New York and that it belongs to New York State. So it's the same idea, but it's a different way of writing. So probably if you are a programmer, maybe this could be more intuitive for you. And then in the OntorionCNL, this is possible. It's possible to write it by saying that New York is a city and belongs to New York State. So as you can see already here, that the blue elements are the keywords, and the dashes are used to make complex sentences, concepts or instances. So I think it's interesting to see that the difference between the mathematical part from the going through the XML representation and the CNL. Then here it's possible to see another example of concept subsumption, in which we say that the intermediate customer is a customer. So this is possible to write in all like this, saying that subclass of, and it is possible to write it in OntorionCNL by writing that every intermediate customer is a customer. Then it's possible also to write, for example, a condition. For example, here we are saying that an industrial customer is a customer that has industry equal to something. This is top everything in the description logic. And in OWL, this is possible to say by saying that the industrial customer is intersection of customer that has some value that is as industry thing. And in OntorionCNL, this is possible to write it like something that is the equivalent of this. Something is an industrial customer if and only if it is a customer that has industry something. So here you see this is a keyword, and it's a keyword that represents something like this, but these 3 things are equivalent, just it's different ways of representing it. Finally, here I present SWRL rule, that is this strange element. Here is the way in which it is written in a logical way. So here we are saying that there is a city, that is city 0, that it's a variable, it's an instance of city. State 0 is a variable, it's an instance of the state element. And then I say that the city 0, if the city 0 and state 0 they are connected by belong to, then the state contains the city. So the idea here, I want to say that that if a city belongs to a state, then the state contains the city. This is the idea of this. So in OWL, but no, sorry, in SWRL, this is possible to write also as an XML, because as I told you, this SWRL rule, it's possible to put them inside an OWL file. So the same thing, so it's the way of writing it, it's very similar. And as you see here, this is a DL safe rule, and you can write something very similar, in which there is a variable here, city temp 1, another state temp 1, then you say that city temp 1 belongs to state. This is the hypothesis, and if this is true, then state contains city. So the logic is clearly the same because it's a representation of this, but it's another format. And in OntorionCNL, it's possible to write it very simply by writing that if a city belongs to a state, then the state contains the city. As you see, this is much more similar to natural language, and it seems quite natural to write a rule like this. Okay, so this was just an introduction, and now I would like to go through some basic concept of this OntorionCNL. And so the OntorionCNL is control natural language, as I told you. As you already have seen, in OntorionCNL there are some conventions. So dashes are used for concept names, that's complex concept names. So very beautiful girl, it says to have dashes between them. And then each OWL name is possible to translate it to a CNL name and vice versa. Then it is possible to define a class when they are used for the first time. In this case, for example, we are defining person and parent. Then it's possible to write instances. This also we already saw that John is a person. This means that this is an instance of this concept. And this is the equivalent of what generally in OWL it is. So that John instance of person. Also the instance names can be complex, like we saw for the concepts, by adding dashes. Furthermore, here you see that using this construction, the something, you can put inside here everything you want as a name. For example, every type of UTF-8 character. And then again, you can translate the OWL to the CNL and vice versa. And then what's interesting is that all our being the OntorionCNL compatible with OWL, it's also inheriting some of the ideas of OWL. So one of the most important idea is the idea of linking. So also in OntorionCNL, it is possible to define a namespace of the things you are writing, exactly as it is used in OWL. Plus, you can add references inside the file. For example, here I am adding, in this line we are adding a reference that is called family, and this is how we will use it inside the file. And this is the location where you can find the file. Here you see it's a CNL file, but it's possible to link every kind of OWL file or RDF. And here it's locally, but also it's possible to do it on the internet. And then when we are writing in the CNL, we are writing something like Mary is a woman, and here we are giving the namespace, and so we know that this woman will be taken from this namespace. So this is exactly how in OWL it works, but here we are doing it. It's the way in which it's possible to do it in OntorionCNL. So then now I would like to show you very briefly, because then I will present you a working example, but I will present the idea that is behind the Fluent Editor and Ontorion. So Fluent Editor is an editor for ontologies and for in general to modify, create ontologies. It is a predictive editor in the sense that when you are writing, it is hinting you what's the best thing to write after, and also it has a taxonomy tree that of the relations of the elements that are inside the ontology you are writing. And And also inside the Fluent Editor, it's incorporated a reasoner, using which it is possible to make CNL queries to the ontology. So the idea behind Fluent Editor is to integrate Fluent Editor with all the existing semantic web, and so it's a program that you can use to model ontology, but also to refer all kinds of other ontologies in the web or locally or on your database. Then another program we are developing is Ontorion, and Ontorion is a program that the idea is that all the core code that we have developed for Fluent Editor, it's possible to use this to create a server application that has inside some components. So this server application is working on top of Cassandra, so it's completely scalable, so it's possible to build really big data semantic database with this. But also we have inside a reasoner, exactly like in Fluent Editor, so it's possible to do CNL queries and everything. We have inside the RDF graph of the knowledge base that we are inserting inside, and so having this graph means that we can do SparkQL queries to Ontorion, and but also we are storing the DL logic of the knowledge base. This is because not all the things can be stored in RDF, so we need also the DL to reason everything that it's put inside. And a very interesting feature of Ontorion is that it uses a modularizator to reason only the part of knowledge that is needed to reason, and not that otherwise each time you will have to reason on the whole knowledge base, and this makes it faster and scalable. Okay, and then between Ontorion, from Ontorion we have also developed an API to interact with Ontorion, that using which it is possible to power all kind of applications. So now we stop here for the presentation, and I would like to start showing you a bit of practical examples. So this is the so yes, let's start with this practical example. Here you see that we have made this Italian dinner file in Fluent Editor, and this is a file in which we have defined, as I showed you before, the namespace of the whole ontology. And then inside the file we are using some references, for example this pizza or wine, that are references that are written here, wine and pizza. And as you can see, one of them, wine, is taken from the internet, so and we can see if it's valid or not, and it will parse the RDF or the OWL, and here the other one is local, as you see, it's in my computer. So then having this very simple ontology, I just define my pizza as a pizza and things like this. But you see that I can ask to the reasoner, here it's the Hermit reasoner we are using inside, and we can ask, what is my pizza? So my pizza is this, and as you can see, I defined inside the ontology only that my pizza is a pizza, and nothing else about my pizza I have written down. But as we are referencing other elements, we can write my pizza, and I will get back that my pizza is a cheesy vegetable topping pizza, and this is because it's taking it from the reference. And here, for example, that we can say that every time that my pizza, every pizza, my pizza is everything of this, for example, non-vegetarian pizza. And this is one example. The other example I would like to present to you is a knowledge base that we have wrote to represent a group of customers. So it's a very simple group of customers. So there are 4 types of customer, but one of the type of customer is a reasoned customer. So it's a customer that is an industrial customer if and only if it is a customer as industry something. As you see, this is the same example that I was presenting to you before. And here interestingly is that the interesting thing is that in the industrial customer is defined by a reasoning. So it's not appearing here in the taxonomy tree, but you will see that it's there. That it's possible to find out which one is industrial customer. And yeah, so there are customers that lives in states, and each state has cities and things like this. And then each customer is paying some bills. So we can see, for example, the bills, that there are bills, they have date paid, they have some price, and then you can see that, for example, we have some customer that it's an internal customer, things like this. So then you can use the reasoner to understand, for example, who or what is an industrial customer, for example. Here my computer is a bit slow, so it will take some time, but in general it's not like this. So for example, here it's answering me that all these customers, all these instances that are customer are also industrial customers. So to see this, let's see this 937, for example, that is this 937, and as you see, customer 937 is defined as an industrial customer because it has industry something, software in this case. So this means that you can do this has been reasoned using the rule that we have wrote here, that it is an industrial customer if it has industry something. So okay, I will not go further here because I will present this exactly the same on Ontorion. So Ontorion, as I told you, is a server application. So at the moment Ontorion is running here on my computer and locally. So but here in this case it's running on the cloud, on an Azure cloud. So in this case we will use an Ontorion remotely. And this application has been developed using the SDK API, the API, Ontorion API that we have developed. And using the Ontorion API, it is possible to use it to do any kind of application. Here, for example, we have developed an ASP.NET web application. What I would like to show here is that using the Ontorion API, it is possible to do an application that works very similar to what you have seen in Fluent Editor. So here, for example, we have the same knowledge base that you have seen before, but it is displayed using HTML. And here, for example, we have used a property of the customer that you already saw before in the knowledge base. So that customer, for example, F's photo, and I use this photo to show it in the application. So then the same thing can be done, for example, here, where you show the map based on the latitude and longitude, or yeah, and the latitude and longitude of the state, and you do the same thing. Then, exactly as in Fluent Editor, it is possible to ask, for example, for industrial customer, for example, and you will see that we have the knowledge base is the same. We have less result because we have less industrial customer, but you see that all industrial customer are from some chemical, some industry, like we already saw. So this is the part, the ask part of this web application, in which we are doing CNL queries. Then there is also the edit part, this one, that's where you can load the information that we have stored about some kind of elements of the ontology inside the database. So for example, here you can see that this is the information that we have stored about customer 346, and this, as you can see, is exactly as you have seen in Fluent Editor. So it's as emailed something and things like this. And but another thing that is interesting, as I told you, is that we can directly use SparkQL queries, because as everything is stored in RDF database, this means that we can use SparkQL queries like a normal RDF database, and so we can choose, for example, not to show ED that you see here, and so for example you can do something like this. Interestingly enough, it's also possible to use the whole Ontorion as a SparkQL endpoint. So this is the link, and using this you can use it as SparkQL endpoint. And okay, I will not show this because but it's possible to show that it's directly possible to connect to Ontorion. And then it's possible also to import and export all the things that you have stored inside Ontorion. Now, to finish, I would like to present you the Ontorion SDK, and so to show you how it is structured, because here you see I have installed it in my computer, the Ontorion server, and in the Ontorion server there are two folders. It's a bin and SDK, and in the SDK folder there is the bin, where you have an application, client standalone console, that is an application for command line like this, in which you can use many properties, for example create database and things like this, directly using the API. And then here you have a way of making this kind of this API, the client of Ontorion, making it a service that you can then use in other kind of applications. Then inside this SDK we have added, apart from the documentations, also the samples. For now we have one sample, that is the Ontorion demo app. So the Ontorion demo app is here, where I opened up in Visual Studio, and this is this application is referencing this Ontorion API client that is here, that is inside this inside the SDK bin folder, and yes, in this, as you can see here, what we are doing is that we are instantiating this interface, this API interface, that with some connection parameter, and then we are starting by dropping a key space. So I will start this, dropping a key space if it exists, but otherwise we are creating a new key space that now it's called testDB, and we are storing information about this key space inside the server here, save changes, and then we are starting to retrieve the information about what we have stored inside what we have stored inside. So here now, yes, as I already told you, my computer is a bit slow, but you see this is Ontorion server, is started to work, and it started to do, for example, it's modify knowledge base, and here the application is starting to do all the things that you have seen before. So we are asking about super concepts, sub concepts, direct, indirect sub concepts and super concepts and things like this. And here put a breakpoint in the part where we are, for example, doing SparkQL query on the database, and so here we have the answer. So as you can see, all of this is exactly what you already seen in the web application, only that that now it's that I did this application just to show you that how it is simple to use the API to then use the Ontorion functionalities. And clearly this that now it's on my computer, Ontorion, it's not important, it can be anywhere. And you see here I read the module about John, then I found super concepts, sub concepts, and things like this. And here I have the results of Spark Web Query. So yeah, I think I will stop here because there are already many things. Then if you have questions or anything, you can ask me.